Hi folks, I'm Dr. McNamara and I'm going to be your lab instructor for your Stat 220 labs this semester. And the labs that I teach use R, which is a programming language. There's a bunch of different ways to use R, one of which involves you installing a bunch of stuff on your own computer. But to make things simpler for you, I am suggesting that you use an online version of R on RStudio Cloud. So if you go to the Canvas page, there should be instructions on how to sign up for an account on RStudio Cloud and join my workspace. And I'm going to try and walk you through that a little bit in this video. So if you go to that first link about signing up for an RStudio Cloud account, you should get brought to a screen that looks like this. If you have a Google or GitHub account that you want to use as a single sign-on, you can use one of those. But I think most people will sign up for an account with an email address and password and their name. You can use your St. Thomas email address or another email address. It doesn't matter to me, but you'll need to go through the process and sign up. I'm not going to do that right now because I already have an account, but I think that it'll be like signing up for most services where you get an email and you have to go click on the link in your email to confirm your account. Once you've done that, you should be able to log into RStudio Cloud using that account that you just created. So I'm going to use my kind of fake student account and log myself into RStudio Cloud. And when you log in, you're probably going to be brought to a screen that looks like this, your workspace. You might have that sidebar or you might not. I have already joined a bunch of projects, so I have some stuff there, but yours probably looks pretty blank. And so this is your workspace where you can create things, but what I'd really like you to do is join my workspace. So there was a second link on Canvas, which was an invite link to my workspace, and then you could go to that link, and I'll do that as well. So when you go to that URL, it's probably going to ask you a question like this. Do you want to join the space? Yeah, you want to join my space. And then it says, welcome to Stat 220. And then what you're going to want to do is go to projects. Projects is where all the good stuff is. And you should see one project, which is called labs, and it will say start next to it. And so if you want to get started, you can click where it says labs. And this first part takes a second because RStudio has to make a copy of the work that I've set up for you in your own version. And so it's gonna just sort of like deploy the project, prepare the project, and then hopefully pop something up for me. Great. So this is what RStudio looks like when you first get started. And it's broken up into a number of panes, like window panes that break up the screen. So I think about there's this pane here. This is the console. Then up here, we've got our environment pane, which also has a history tab and some other things. And then down at the bottom, we have our files pane, which shows us the files that we have loaded on RStudio Cloud. So I'm going to start in the console pane, and the thing that you can do in the console is you can type R code. We're not really going to get started doing coding this week. We'll do like maybe a tiny bit of code, next week a tiny bit of code, and then the week after that we'll really get into it. But R is essentially like a big calculator. So anything that you could type into a fancy calculator, you can type into R. So if I wanted to do 2 plus 2, I could type that in my console and hit enter, and R would say 2 plus 2 is 4. Okay, I believe that. If I wanted to take the log of 4, I could do log parentheses 4 and hit enter, and it says it's 1.386. All right, I believe that. If I wanted to find the square root, the SQRT parentheses of 100 and hit enter, the square root of 100 is 10. So if you wanted to just do some math, you could do that in R. But the thing that makes R really cool is that it's been designed to do data analysis and statistics, and that's what we are going to use it for. So I have preloaded a bunch of files for you in your files pane. So if you remember, that's this part kind of over here. So if you see there, there is a folder called labs. That's where all the real labs are. There's a folder called prelabs where there are some prelab files. There's this convenient file called all the R you need, which has an overview of every single piece of code we're going to learn all semester. And then there's a couple kind of helper files, the .r history and the project.rproj. These are just kind of like preferences and things that make RStudio work nicely. So the way that the lab is going to work is that every week I am going to give you a video that goes along with a pre-lab, and I encourage you to watch the video and work through the pre-lab so that you can learn the skills that you need in order to complete the real lab. So let's try that for this week. So let's click on the pre-labs folder and go in there. So once you get in here, you're going to see a bunch of files. There is a pre-lab for every week. This week, the pre-lab is describing data. So I can click on this file that says describing data prelab.rmd. And now an additional pane opens up in my RStudio. And this is where I suggest that you write your code. So I already have some sentences written in here, and I've got some code. And then there'll be questions and things that we will fill in as we go along in the pre-lab. So like I say here, we use one main package in this course. It's called Mosaic. And the thing that is super powerful about R is that there are all these packages that help you do things beyond just log and square root. So we're going to use the Mosaic package because it has a bunch of functions that I want to teach you. And if you want to load a package, you use the library functions. You type library parentheses, and then you put the name of the function inside the parentheses. So Mosaic. And then if I type this into the console and hit enter, some red text is going to scroll by. And that actually means that things have worked. It's just giving me some information saying that, the Mosaic package is going to mask some functions. It's kind of going to overwrite them, but the original behavior should not be affected. And then it just tells me what those functions are. So this red text is actually good. And that's one way to run R code, is to type it in the console. The other thing that you can do is that there are these green sort of play buttons. It's like a little triangle. And if you click the green play button, then it will run the chunk of code. So it ran these 2 lines of code. And nothing printed out because I had already loaded the Mosaic package, so it didn't feel like it needed to tell me those messages again. So we are going to work every week with the same example data set. And I've put it in this data folder over here in my files. So if I click on data, I can see there's just one file inside that folder. It's called gss_clean.csv. And this is data from the General Social Survey, which is a big random sample of households in the United States. They ask a bunch of people a bunch of questions about their demographics, like how old are you married, things like that. Then they ask them their opinions about a bunch of things, like should we have more funding for infrastructure, should marijuana be made legal, things like that. So I went and got some data from the General Social Survey, and I put it on RStudio Cloud for you, and we're going to use that when we do our pre-labs. So even though the file is in the files pane of RStudio, it's not loaded in for R to actually be able to work with. And so we need to write some code. And if you look here on line 19, there's a pound sign, and it says this is where data loading code goes. A pound sign in R is a comment. And so this is just, it's not really code, it's just a little message from me to you, and it's totally fine to delete it. And now I can put the code that I want to write in there where the comment was. And the first thing that I need to write if I'm going to load some data in is what I want the data to be named. And I can pick any name that I want. I could pick Amelia, that's my first name. I could pick my very cool data. I I could call it A. I can name it whatever I want. But it makes sense to pick a name that you will remember and that's kind of easy to type because you're going to have to type it a lot. So I'm going to call my data GSS, capital GSS, for the General Social Survey. And I usually put a space after I've written the name of my object. And then I need to write the assignment operator. And so that assignment operator is the thing that says, like, this code is going to go into an object with that name. And the assignment operator in R is a little arrow. And the way that you make it is you do a less than sign, and then you do a hyphen or a dash. So it's a less than sign and a dash, and it points toward the name. So now I've got GSS, I've got that assignment operator, and I usually put a space after that. R doesn't really care about spaces, but it makes your code look nicer. And then in the same way that I showed you how to use the log function and the square root function, we're going to use the read CSV function. And here's how it works. So I type read.csv, and you can see that RStudio is trying to help me. It's saying, there's two functions that start with that. There's read CSV and read CSV2. I want read CSV. So I don't need to use any of those. But as we start working on other things, sometimes that suggestion functionality is helpful. So I've got read CSV, that's the name of my function. And then after the name of a function, you always put parentheses. So I'm going to write parentheses. If I write the left-hand parenthesis on my keyboard, RStudio automatically fills in the right-hand parenthesis on the other end to sort of close off that function. So that's helpful as well. And then I'm going to need quotation marks. And again, if I type one quotation mark, RStudio completes it and it puts the other quotation mark for me. And now what needs to go inside those quotation marks is the file path to the file that I'm going to load. And if you're good at typing out file paths, you can just type this. I think the easiest way to do it is actually to hit the tab key on the keyboard. So if I hit tab, it shows me all the things that are in my folder. So there's other Prelabs, and I can use my down arrow on my keyboard to go down to the data folder, because that's where my data is. And then if I hit tab, it'll jump me into that data folder and it'll show me everything in that data folder. And there's just one thing, gssclean.csv. So I'm going to hit tab and it'll write that in for me as well. So if you wanted to, you could have written that all out on the keyboard. data/gss, capital letters, _clean.csv. That would work as well, but I like this tab trick. And now that I have that code written, I can click the play button to run that code. So when I click this, kind of nothing happens. I don't see anything printing out down here, but over in my environment, now I have something called GSS. So this is my data set. It's in the data section of my environment, and it gives me some information right off the bat. So it says this GSS data is 2,348 observations of 45 variables. So with the first lab, this would actually help you answer a couple of questions. So let's think about the sorts of things that we can answer by looking at the data in RStudio. And again, we're not really going to do any more programming this week. That was our line of code that we're going to write, and now we're just going to think about the data. The first question is, what are the cases in the data set? And that means, what are the observations? What are the rows, if we were thinking about this as kind of like a spreadsheet? And one thing that RStudio gives you is kind of a spreadsheet-like way to look at the data. So if I go over here and click where it says 2,348 observations, RStudio is going to pop up a little preview of the data, and I can scroll around. So this has 45 columns because there's 45 variables. So there's a lot to scroll to the side, and it has 2,348 entries, so it's a lot to scroll down. So I could look at this first row. It says respondent ID number 1, number of children 0, age of respondent 43, highest year of school completed 14. So that's high school plus 2 years of college. highest year of school completed father, that's how much school their dad did, 12 years. Their mom did 12 years. Their spouse, it says NA, so either they're not married or their spouse didn't go to school or they didn't answer the question. It says their college major was communication speech, and it looks like they didn't have a second college major. So those are some of the pieces of information that we know about this observation. So then the question is, what sort of thing is this observation? And this is kind of a thinking question. The data can't really answer for you what are the cases in the data, but I'm pretty sure that the cases in this data set are people. In the data set for your lab, the cases might be trees or cells or documents. It could be any kind of thing that you could observe something about, but in my case, they're people. Then it asks, how many cases are there? How many rows in the data set? And I can see that in my environment. There are 2,348 cases. Is there any missing data, and how can you tell? So let's go back to the spreadsheet-like version here. And missing data in R is represented as NA, and it'll be kind of gray. So I can see some here in the highest year of school completed father. There are some NA values. So again, maybe they don't have a dad, maybe they don't know how much school their dad did, maybe their dad didn't go to school, but there's an NA here. We saw a bunch of NAs for highest year of school completed spouse. We've got some NAs for college major. Maybe they didn't go to college or they didn't want to share their major. Lots of NAs for college major too, because a lot of people just get one major. So yeah, there's kind of a lot of missing data. There's quite a bit of missing data. We can see it as NAs in the preview. Okay, so that was about cases, missing data. What are the variables? So variables are the columns in the data set. They're things that can vary between people in this case. So the number of children can vary. Some people have a lot of kids. Some people have just a few. Some people have no kids. Age can vary between people. The highest year of school completed, that can vary between people, etc. So each one of these columns is a variable. So there are lots of variables, 45 in fact. And what are some of them? Some are age, number of years of school completed, college major. There were some more of them. One thing that we can do to remind ourselves of the variable names is click this blue sort of circle with a triangle in it next to where it says GSS, and then it'll remind us of the names of the variables and it'll show us the very beginning of them. So there are some of the variables. We have their labor force status. Maybe I'll write that. Why won't it let me click? There we go. Labor force status, their marital status, lots and lots of things. And then we want to be able to remember the difference between a quantitative variable and a categorical variable. So quantitative variables, those are the things that are like numbers. So that would be things like number of brothers and sisters, number of siblings. Let's see, are there some other numeric variables? Number of people in household, the size of the place that they live in thousands. Weirdly, I think that age is actually not being represented as a number in R right now. And we could go look at that. So age, it looks like a number, 43, 74, 42. But if I click the sort button, okay, the youngest people in the survey were 18, so they're just interviewing adults. Sort it this other way. Then there was an option of 89 or older, and that's not a number. And so R made everything into a character, a sort of categorical variable. I'll sort back by respondent ID number. So I'll put age, sort of. Oh, and these are my quantitative. And then let's do the categorical. Lots of other things. College major, their labor force status. So that's like, are they employed or not? Let's see, their marital status. That's like, are they married or not? Things like that. So quite a few categorical variables. Something that the real lab will ask you to do is pick out a particular observation and learn some things about it. So let's try that in our data. So we could look at the first person, maybe let's look at the second person. So respondent number 2, they have 3 children, they're 74 years old, and they got to 10th grade. So let's write that out. So the second person is, oh, I already forgot, 74 years old, completed 10th grade, has how many children? 3 children. And we could go on and read about this person. So their dad didn't go to school, their mom did 8th grade, NA for their spouse, NA for their college major. That makes sense because they didn't finish high school. Looks like they got their GED, so that's good. They're female. They have 4 brothers and sisters. They're retired, so they didn't work last week. They don't usually work. Do they work for someone else? That's weird. They're retired, so who do they work for? So this is like already we can kind of see there's weirdness in data, and we're going to have to deal with that as we work through this lab. All right, so those are some characteristics. And then the last thing is, what is a question that we could answer using this data? And the questions that I think are the most interesting are ones that involve 2 variables. So maybe like, do married people work more hours than divorced people? That sounds interesting to me. Or do people with more brothers and sisters have more children? Or is there a relationship between general happiness? We asked people, how happy they are, and total family income, right? Does money buy happiness? So lots of questions that we could ask using this data. All right. So those are some questions that we can answer. We're just kind of clicking around in RStudio so far. The only other thing that you might need to know for this lab is how to take a screenshot. I'm pretty sure this lab asks you to take a screenshot of the data, and so you need to know how to do that. I've linked to how to take a screenshot on Windows and how to take a screenshot on Mac. I'm a Mac person, so I'm going to put this link in to my browser. And it shows me that I can, I can take a screenshot of my whole screen with Shift Command 3, or I could capture a portion of the screen with Shift Command 4. So I might go to GSS and then Shift Command 4 and drag over that data to have a screenshot to upload. I'm not on a Windows machine right now, but there's similar instructions on WikiHow to take a screenshot on Windows, and I'm happy to help you with that during our synchronous time together.